Assalamualaikum and hi. So today I will explain a little bit about Lab5, which is the cryptography and the certificate. So basically, we're moving on to the question. So for the task 1, which is the question 1.1, the question asks what is the maximum amount of the time that it would take for a computer that can try 1 million RC key every second to do a brute force attack on a Microsoft Office document sealed with a cryptographic transformation that use a 40-bit shell secret. So we got the answer, which is in 2004, a typical home computer could brute force a 40-bit key in less than 2 weeks by testing a million key per second. The machine can perform a task significantly more quickly, and then using at the time on a large corporate network or botnet, a 40-bit key can be cracked in seconds. So basically, this is our calculation. Is it right? So basically, the RC2 is equal to 40 bits, and then we got the 1 million RC key is equal to 1 second, and then we need to do the conversions from second to minute, which is, as we know, 60 seconds equal to 1 minute. And then we got 1.1 multiple with 10 power of 12. Then we got the answer, which is 1.1 multiple with 10 power of 6 seconds. And then the next thing that we need to do, which is the conversion from second to minute, which is 60 seconds, it will be equal to 1 minute. And then we calculate based on the calculation, and we got the answer, which is the 16.667 multiplied with 10 to the power of 3 minutes. And then we going on to the next step, which is we need to do the conversion from the minute to hour. We know the 1 hour is equal to 60 minutes, and then we'll multiple the answer, and then we got 277.7833 hours. And then lastly, we need to do the conversion from our 2 days, and we know 1 day equal to 24 hours, and then we calculate based on the equation. Then we got 11.57 for 1 day. So we just estimated about 12 days. So we're moving on to the next question, which is the 1.2. The question is Microsoft Office 2003 used the AES cryptographic transformation with a 128-bit share secret to control access to document controlled by Windows Write Management Technologies. If AES key can be tried with the same speed as RC2 key using the computer described in the question 1.1, what is the maximum amount of time that it would take for a brute force attack on a single document seals with the Windows Write Management Technology? So basically what we do is we need to figure out that the AES equal to 128 bits, and then we need to do the conversion, from second to minute. We know that 60 seconds equal to 1 minute, and then we got the 3.403 multiplied with 10 power of 30 second, and then based on it we got the 5.6717 multiplied with 10 power of 30 minutes, and then we need to do the conversion from the minute to hours. We know that 1 hour is equal to 60 minutes, and then from it we can get the answer, which is 9.4528 multiplied with 10 power of 28 hours. And then lastly, we need to do the conversion from hour to day. We know that 1 day equal to 24 hours, and then the answer we need to divide it with 24 hours. So we got 3.9387 multiplied with 10 power of 28 days. So basically, that's the question that I showed the explanation of it. So the other tasks my group members will explain about it. Thank you.
Okay, so next for the question 1.3. The question is, how does your answer to question 1.2 compare to the age of the universe, currently estimated at somewhere between 13.5 billion and 14 billion years? With advance in technology, it may be possible at some point in the future to have billion of high-speed computer in a very small volume. So the 128-bit is superior, okay, because it is more secure. This is because the processing require the additional time. And then for question 1.4, if you upgrade your computer to the system that has a billion processing element, each of which can try a billion keys in a second, is your secret still safe from attack? So the answer is the secret is still safe because the higher the bit of processing element, it is more secure. Okay. And then question 1.5, if you start with a computer today that can try 1 million keys every second and every 18 months, you throw away that computer by another for this project that is twice as fast. How long will it be until you have tried all possible 1 to 8-bit AES ceiling keys? Okay, so one of the challenge in mounting a successful brute force is that your program need to be able to have some way of recognizing when it has guessed the correct key. Sometimes such recognition are easy. The seal text descript to English or another human readable language. The program can be later frequency analyzed on the resulting text and determine if the entropy is low or high. Low entropy indicate that the unsealing operation was successful. Recognizing a correct key become trivial if the decrypt message include a checksum or message authentication mode (MAC). In general, the longer the ciphertext, the easier it is to recognize when a correct key is guessed. So here the clue that been given. So what we need to do? Okay, first we need to convert from million to second. Okay, so here how the calculation been going, and then convert from second to minute. Okay, and then convert it from minute to hours, and then lastly convert from hour to day. Okay, so one day is equal to 24 hours. So here we got 1.98 multiplied by 10 to the power of 27 days. So this is the answer. Okay, how long it will be? Okay, so this is the answer that we got. Okay, next for the part 2, my other lab partner will be continue.
Assalamualaikum sir, my name is Muhammad. Assalamualaikum sir. I will explain about the part 2 in this episode. Okay, basically here is my short.
Okay, Azim, you can continue.
Okay, I will begin to run the example that have been given in this lab sheet. Okay, firstly we need to save. We need to create a notepad file by inserting university in this document and then save it. And then we open the command prompt and then change the directory to desktop. Okay, once we are in the desktop, we have to copy this command, this line of command. It's it on. Okay, so this is the output that we got when running this example, and then we try it by different file types. Okay, so we need to copy here. And then save, and then we run it again. As you can see here, the output is quite the same. So the observation from question 2.1 and question 2.2, both questions could have led to the conclusion that the hash file for both codes had changed to a completely different hash code. This occurs because even if one bit in the file is changed, the secure hashing algorithm will generate a new hash. We could also conclude that the content has been altered based on the new, completely different hash code. So from me, sir. Thank you.
Okay, so next we proceed to the conclusion. So as a conclusion, we'll be able to illustrate how complexity is happen in the coding. Other than that, we also be able to develop a suitable algorithm for cryptography and certificates. Next, we also be able to analyze the requirement for creating key for security. Then we also can discuss the result from this experiment and present technical report. Last but not least, we can complete every task in this experiment effectively in a group. So that's all from us. Thank you.